Embarking on the complex journey beneath the Earth's surface, we delve into the intricate world of oil drilling. Unlike the familiar imagery of poking a straw into a rolling orange, the process is far from simplistic. Picture a ballet of machinery, where every move must be precisely choreographed to extract the lifeblood of our modern society. Join us as we uncover the details of this multifaceted and often perilous procedure, revealing the science and engineering that powers our global thirst for oil. The intricate process initiates with the penetration of the Earth's depths through drilling. Employing a lengthy bit connected to a drilling string, this bit exhibits a varying diameter, ranging from 5 to 50 inches. Following the completion of each section, a steel pipe, slightly smaller than the hole diameter, is carefully inserted, often accompanied by the use of cement to fill any gaps. This steel casing plays a crucial role, providing structural integrity to the hole and isolating high-pressure rock areas prone to explosive releases. The drilling procedure significantly differs from wielding a power drill on wood. Notably, the drilled hole is filled with a concoction known as mud, a blend of fluids, solids, and chemicals. This mud serves a dual purpose: lubricating the bit and facilitating the removal of broken rock fragments, highlighting the complexities involved in oil drilling. As the bit moves deeper, new sections of pipe are added to the string. These are screwed onto the top drive at the surface in a process known as making a connection. Once the hole has been drilled, it must be completed or prepared for extraction. Usually, this involves perforating the casing so oil or gas can enter the tube. Sand or gravel is often added to the bottommost reservoir to act as a screen. Fluids, often high-pressure water or an acid, are then pumped through to clean and fracture the rock, encouraging it to begin releasing hydrocarbons. The main reservoir is then sealed off and connected to the surface with smaller diameter tubing. The most important phase of drilling, at least from the perspective of the drillers, is the production phase. This is the period during which oil or gas is actually pulled from the ground. The U.S. consumes 19.1 million barrels of petroleum each day, almost half of it in the form of gasoline, according to the U.S. Energy Information Administration. Thanks to its car culture, the U.S. is the top oil-consuming country in the world, but with the economic recession, dependence has significantly wound down since peaking in 2005, the agency says. By 2035, U.S. total consumption per day is estimated to total 21.9 billion barrels. So how far do we have to drill to get a hold of this black gold? Over the last 6 decades, it's only gotten deeper. In 1949, the earliest year with data available, the average depth of oil wells drilled was 3,635 feet. By 2008, the most recent data available, we were drilling an average of 5,964 feet, a slight decrease from the 2007 at 6,064 feet. Oil is a finite resource, meaning we now have to dig deeper to find it. For most wells, the pressure inside the reservoir is enough to push the oil or gas to the surface. In more depleted areas, however, some other means, like a pump jack, is necessary. A well does not die, but rather reaches its economic limit, the point at which the oil or gas coming out of it no longer covers the costs associated with operation. When this happens, tubing is removed and cement is poured to ensure hydrocarbon reservoirs remain separate from water and the cutoff from the surface. The pump head is then excavated and removed. A cap is welded in place, and the whole thing is buried. With so many steps taking place down relatively narrow holes deep below the Earth's surface, there is a lot of room for accidents to happen. As proven reserves shrink and become more difficult to replace, drillers are forced to search for deeper and less reliable sources of hydrocarbons, and these places are often more difficult and dangerous to drill. The escalating depth of oil wells over the decades is a reflection of our growing dependence on fossil fuels. As we drill deeper into the Earth's crust, the environmental impact intensifies. Deeper wells often require more advanced and resource-intensive technologies, leading to increased energy consumption and a higher carbon footprint in the drilling process. Additionally, the exploration and extraction of oil from greater depths pose potential threats to the delicate balance of ecosystems. The consequences of this deep drilling include heightened risks of oil spills and leaks, as the increased pressure at greater depths makes containment and remediation more challenging. Furthermore, the exploration of more challenging terrains often involves pristine or ecologically sensitive areas, contributing to habitat destruction and biodiversity loss. As we extend our reach into deeper oil reservoirs, the potential for environmental degradation and the associated consequences on ecosystems, wildlife, and climate change become more pronounced. Balancing our energy needs with sustainable and environmentally conscious practices is crucial for mitigating the adverse effects of deep oil drilling. Have you ever wondered, though, how offshore drilling works? Watch out for our next video where we would be exploring that topic. Also, we are approaching our first 100 subscribers. Please help us to meet that milestone by subscribing. Thanks for watching.